Thank you very much. My mic is working? Okay, thank you very much. It's an honor to be here at KCD Geneva. I'm really loving the idea that finally, after like 4 years, having something in Bern and in Zurich, we're now also having something in the Romandie. And it's cool to see that this great community is coming together to share knowledge, and this is also what I want to do. So I'll be talking about KubeVirt for the next 30 minutes. And actually, when I started to do stuff with computers back in 1995, our systems looked more something like that. So we had one platform, we had one huge monolith running, and actually 1995 was the time when Java came along and was released. So then actually the stuff with all those microservices, with those huge platforms started. And when we have a look at how those systems would look like today, obviously we have so many more complex systems. We have different platforms, different technologies, different underlying platform where we deploy our workload, where we deploy it in the cloud, on premises, as containers, or even still as VMs. And as I heard yesterday, when I was taking the CERN visit, that there is obviously also still running stuff on VMs. Who of you has running VMs workload somewhere in production still? So I guess we won't get rid of those, I believe. And this also means for us, cloud-native fans and cloud-native engineers, there is still a lot of work to do, because some of those VMs obviously are kind of maybe not treated that well, and there is a potential to bring stuff together. And this is also actually one of the most important challenges we face, because currently we oftentimes really deploy, manage, and lifecycle 2 separate stacks for more or less the same stuff. We want to run like virtual machines, we want to run containers, and we oftentimes use similar ideas, but done by different teams. And also in the virtual machine world, especially on premises, there is still this term ClickOps, quite common for many operators of virtual machines. So the adoption of cloud-native principles when it comes to virtual machines is actually not that far ahead already. And many of the operations teams faced that challenge with the acquisition of VMware, that they were forced somehow to think of alternative ways on how they could like use and deploy their virtual machine workloads to different stacks, because it became quite expensive. And this is actually exactly where KubeVirt helps us to really give an option to us, so that we can think of how we could manage virtual machine workloads in the future, or even right now. So what KubeVirt does, it basically allows us to run virtual machines, some type of virtual machines, on our Kubernetes cluster, and it also helps us that we can use the Kubernetes API to provision, to configure, to deploy our VM workload. And that's really interesting. So the concepts doing GitOps, which we are doing for some time with our container workload, is now able that we also do the same stuff for our virtual machines. And under the hood, obviously, there is a tool called KVM, which is almost as old as this globe we're currently in. It's almost 20 years old, and it's a technology, kernel-based virtual machines, which basically allows us to run virtual machines as processes. And for many of you, that might sound familiar, because what we do with containers and Kubernetes is actually isolating processes which run on Linux kernels to operate and manage them. So the basic principle here is with Virch and LibVirt, we have the possibility to run processes on hardware, which are basically virtual machines. And this is what KubeVirt then uses. So we encapsulate those KVM processes in containers and run those processes on our Kubernetes cluster. And processes as containers or as VMs, they both have similarities, so they use compute, CPU, memory. They also use some kind of storage and network, but they might be a bit different to treat. And I was told that this little guy up here, currently watching us from above, doesn't still have a name, so maybe if you know a fancy name for this little Verti or QB or whatever name, come to Oleg and tell him your proposals. Very nice. So there was this definition David Wassel from Red Hat once did, that KubeVirt actually is a Kubernetes extension which allows to run virtual machines side by side to containers. This is more or less a bit a human definition. If we go a bit deeper into the technical stuff, actually what it says, what KubeVirt more or less is, we wrap virtual machine processes in containers and use Kubernetes to deploy and orchestrate the stuff. Because for Kubernetes, plain Kubernetes, we don't have the concept of virtual machines. This is something KubeVirt adds with the technology underneath. KubeVirt is actually pretty old already, so since we're in the globe of science and innovation, and I'm talking about technologies which are already 19 years old, and this one already almost 10 years old, so it's nothing new. And that's also the good stuff. It's really proven, it's production proven, it really runs a lot of workload on that stuff already. It was open sourced in 2017, it's a CNCF incubator project, and it has a growing community. Many large, big players are using and also contributing to the technology. We will see some use cases later on. Let's dig a bit deeper into the architecture and the concepts behind KubeVirt. So basically, we have two fundamental design principles. The one is we follow the operator pattern, which means we have a set of controllers running on our control plane, and we have a set of custom resource definitions, which help us to define our virtual machines, our virtual machine workload. And on the other hand, we heavily rely on standards. So we really rely on the Kubernetes standards we know, the CRI, the CSI, and the CNI. And this also means that when you're deploying virtual machines, you can use the components and ideas, you know, from plain Kubernetes with services, secrets, network policies, ingresses, and such to really integrate with your virtual machine. So it's very nicely integrated. We'll have a deeper look on the next couple of slides how that works. So the most important custom resource definition potentially is the virtual machine, and you will also be able to get your hands on that most of the times, which is the representation, as the name says, of a virtual machine. So you can specify what disks are added to your virtual machine, you can specify the interfaces, you can specify the resources, CPU, memory, and you can also integrate into this Kubernetes world. Whenever such a virtual machine is instantiated, so whenever it is started, the Kubernetes operator then creates this virtual machine instance representation, which will give you a lot more of the running representation of such a VM. And then the other stuff I mentioned, since we heavily integrate into the Kubernetes world, obviously we do use those interfaces. I will go through all of them and explain a little bit how that integrates very nicely. From a runtime perspective, KubeVirt is based on two sets of components. So we have the cluster level, the control plane level components consisting out of the Virt controller. The Virt controller basically watches all those custom resources and decides what to do whenever something there changes. And the Virt API. The Virt API basically allows you to run commands like start this VM, stop this VM, migrate this VM. We will see that later in the demonstration. And on the node level, we have a daemon set deployed, the Virt handler. And the Virt handler basically is the component which takes care of handling those virtual machines while they are running as inside a pod. So whenever I want to start now a virtual machine, I obviously tell my API server, I throw it my VM virtual machine custom resources, and based on that custom resource, the Virt controller decides to start a running pod on my node. The kubelet, in that case, will start a pod, which is at that point pretty empty. It just has this Virt launcher process running, which is then configured via the Virt handler and actually deploys a running virtual machine process using QEMU and libvirt-d, which is then encapsulated within the pod. Let's move on. Obviously, networking for virtual machines is very important, and by default, we integrate seamlessly into the pod network. So you oftentimes have this network attachment point directly into your VM, and you can integrate very nicely with your Kubernetes way. But oftentimes, virtual machines have not just one interface allocated and not just one network card attached to the VM. So there is also this possibility with this meta plugin, so-called meta plugin Malthus, which allows you basically to configure multiple CNI plugins on a Kubernetes level, which allows you to also then have multiple network cards within your virtual machine. And this is very interesting for cases like backup networks or migration networks, where you really can divide the actual traffic, the actual production traffic from, like, let's say, the backup traffic within your virtual machine. And from a storage perspective, a virtual machine, a disk which is attached to a virtual machine, basically is represented as a persistent volume, like we know it from the containers. So we create PVCs. On the virtual machine side, it's not a PVC, it's a volume, and we attach those volumes to your virtual machine. So it's neatly integrated, and all the feature set you have with storage, like snapshotting or cloning stuff, which is provided by the storage provider underneath, is also applicable to virtual machines. One special case we have when we do live migration from virtual machines, so moving them from one running node to another running node, we do require RWX storage and RWX block storage, which is not that trivial, as you can imagine, because we need to mount those PVs to two running pods at the same time so that we can do the migration. When we deploy those images, oftentimes similar to containers, we need a functionality to configure our virtual machines. And there is this concept of the startup script, where you have multiple options. Many of you might already know. So you kind of take a plain disk image, you add some configuration to it during the startup time or doing some build time, and then actually you can use Cloud Init, sysprep, or Ignition to really specify the state of your virtual machine in a declarative way. I'm going to show you that as well in the demonstration so that you can see how that works in detail. And obviously, if there are the idea of migrating and moving huge, large amount of VMs from one hypervisor to, let's say, a KubeVirt installation or a KubeVirt platform, there is this migration toolkit which is based on Forklift, which allows you really to plan huge amounts of migration. So you can migrate thousands of virtual machines into your new platform, and you can also do warm migrations, meaning while the old VM on the old hypervisor is still running, you can migrate those VMs into your new platform, and then with a short interruption, migrate it completely into the new stack. So let's have a look at how that really feels in your hands. First, I'm going to tell you how the setup, the demo setup actually is. So we have two nodes running in our Kubernetes cluster. We will deploy a Fedora VM, which has inside an Nginx running on port 8080, and we'll connect this 8080 Nginx to the internet using a Kubernetes service and an ingress. And while we'll do that, we will start on a migration, the idea of migrating this running virtual machine from one node to the second node, because this is oftentimes a use case many of the traditional hypervisor guys like to see, and also works very nice on their traditional platform. We then copy the state of the memory, the state of the CPU, the state of the VM from one node to the other node, and restart or start the virtual machine on the second node, while the service then will hit all the traffic we're creating from the outside to the new virtual machine running on the second node. So, before we start, I've deployed, or I created this virtual machine manifest on our platform. As I mentioned before, you can configure everything that desires you, everything you want, from disks to networking to resources, even liveness and readiness probes. Whether that's a good idea or not is something I leave up to you. Virtual machines having readiness probes, because they oftentimes have a bit longer startup times, might be a bit tricky, but it helps you to control your traffic, obviously. And then back down here, we created 3 volumes. So the basic Fedora 34 container disk, which is the basic disk which we will use to configure our workload on it. Then we attached this cloud init disk, which is basically a secret, a Kubernetes secret containing a receipt on how we want to configure our virtual machine. And for demo cases, I also configured a config map containing a HTML file, which will be served. Let's start the virtual machine while I explain you a bit more of those components. So this is the secret containing the cloud init file. Obviously, it does make sense that it is a secret, because as you can see, we do have confidential information. In that case, the password, which is not a good password, obviously, but you would also have private keys in it or stuff like that, so that you configure your platform. Then what we do, we install this Nginx while the VM is starting and the cloud init run is running. And we also configure this Nginx, so we tell it that it should run on port 8080, for example, and also that it would serve this directory to the internet whenever I call, whenever I hit my Nginx with requests. One interesting part then is the run command part. As you know from Kubernetes, whenever you mount a config map into your pods, that's really easily done. You can simply add mount points and that works nice. That's not the case for VM. So what we do here, we create this mount point. We mount the actual disk, which was given to me by the platform, by the KubeVirt platform. In our case, we copy the content from that mounted config map, because it's also read-only, to this share, which we then provide to our Nginx, make sure that the access rights is correct, and make also sure that the Nginx is started and would run. This helps us to see that when we have a look at our virtual machines, that our virtual machine is running since a couple of days, actually. The virtual machine manifest. The instance itself is not running since a couple of days, but since 120 seconds. And it also has a node attached, as you can see. So it's really running on my Kubernetes cluster whenever I started it. Let's quickly, yeah, that's perfect. So whenever we start, as I mentioned, whenever we start a virtual machine, there is the representation of a pod. Obviously, my process is running in a pod. So we can also see, check the pod which is running, this Word Launcher pod, which contains of 3 containers or 3 sub-processes. Whenever I want to connect to a virtual machine, I can use this virtctl command, console, and Fedora VM was the name, I believe. I obviously can also install SSH in my virtual machine and SSH into my machine, but in that case I can easily also connect to the console. Fedora was the username, and KubeVirt a very secure password. So I can see now I'm inside of my my virtual machine running the Nginx somewhere on a port 8080. So I'm now really inside of this KVM machine running on my Kubernetes cluster. Very well, let's exit. So on that side here in the second terminal, I now hit a while loop, which hits the API all the time. I can maybe quickly show you that there really is something going on. So this hello KCD content was on that config map, and I can now hit my API like once in a second to show how the interruption will be whenever we will migrate this platform. So whenever we have like connection losses here, it's also because of the Wi-Fi, but also because we are going to migrate the virtual machine soon. So whenever we start this migration, there are several ways to do that. We can simply hit the migrate of the name, and we need to be quick that we also see was too quick, that we also see what we should see now is slowly the virtual machine is changing from one node to the other node. On the other side here we do have some connection losses while the virtual machine is back, but like after 5 seconds the virtual machine was transferred, the whole state, CPU and memory was transferred to the other node running actually on the cluster. I haven't been running 2 nodes on my machine. And in my demonstration case, we do use CNI, which doesn't keep the IP addresses, which also means on a TCP level you would have to recreate the connection. But there are solutions, and there are also specialists in the audience who know how to really configure virtual machines together with the appropriate CNIs. As I mentioned before, we can now also do GitOps stuff with our virtual machines. In that case, I've configured a virtual machine a replica set, which is pretty similar to actually scaling up pods. We can also scale up virtual machines, which would allow us then obviously to also run those processes which we know from containers with virtual machines. Wonderful. Let's head back to the demonstration. So obviously, KubeVirt is a technology that helps you and allows you to do all the stuff. There are use cases which don't run that well on KubeVirt, and obviously it really needs to be adopted by your team, by your organization, to really get all the benefit out of it. One of the really nice benefits, as I mentioned in the beginning, also as challenge, is that we really can make sure that we bring those 2 stacks, those infrastructures together, and that we can start using the same workflows to manage virtual machine workloads and container workloads. This gets a bit of efficiency, and you start to think of virtual machines as we do it in the cloud already, but you have the possibility to use the Kubernetes API to do stuff like that. And what it also helps, we can treat pods and virtual machine instances or virtual machines as manifests which we put in Git, and we can do GitOps like we do with any other configuration, which helps us to align our processes and also to use this declarative approach on how we manage and treat virtual machines. And since it's so nicely integrated in the Kubernetes world, you also get the benefits of everything around Kubernetes, all those operators and controllers and principles we have, you can use pretty nicely. And there is this nice case from Swisscom. They had this workshop yesterday. There is also the case study out, and I believe in August this year this was promoted. Their stack, their Kubernetes as a service stack, is based on KubeVirt. I believe there will be a second talk this afternoon or lightning talk about similar stuff here, which is really nice to see that those technologies come along and really benefit us to run Kubernetes as a service. One of the famous ones is GeForce Now. So it's a PC gaming everywhere solution which runs your high-performance games in a data center. They use KubeVirt to virtualize your gaming experience, basically, and they render that gaming experience and stream it back home to your low latency device. So you could even run those games then on your TV with a matching controller and stuff. So it's really neat, and they have data centers all over the world. And Cloudflare have been in a bit of a bad light lately, but they also use KubeVirt. I do hope the downtimes also today, I've heard that we had some issues with Cloudflare, that it wasn't because of KubeVirt, otherwise my talk wouldn't make too much sense, but they use like KubeVirt to provide kernel near platforms for their development teams so that they can test and run stuff which is tight integrated into the Linux kernel. So let's come to a bit of a conclusion. Yes, KubeVirt is a nice technology that allows to run virtual machine workload in parallel or similarly on a Kubernetes platform. But there is a but. We cloud-native engineers, or at least I as a cloud-native engineer, I don't have that knowledge that my colleagues built up over the last 10, 20 years to manage hardware, to manage bare metal, to manage network, storage, and stuff. And we cloud-native engineers, we need to learn that stuff because it's not just simple, it's complicated. And what they've been doing on the old stacks, on the previous stacks, that was great work, and we really need to adopt those principles and also this mindset and learn on how to do that. A one-on-one migration, so if you have this SAP virtual machine, which is like using half a terabyte of memory with 46 CPUs, might not be the best case to really migrate to a machine, aside from the support perspective, because KubeVirt and KVM hypervisor isn't yet SAP is not yet supporting those things. And as I mentioned, we need to culturally adopt, so we need to learn how that we can treat VMs similarly to what we do with containers, obviously. And we also need to learn from the other side that we, as I mentioned, that we learn how to run infrastructure workload, how to run hardware again, since we start to bring that topic back to us. There are some alternatives in the cloud-native space. So there are tools where you can do similar stuff. Think Rust-based alternative to QEMU. It's a bit more smooth and quicker. Virtlet actually is not maintained anymore, but what Virtlet does was it implemented an own container runtime interface. So they really brought their own container runtime. This was the way on how they were deploying virtual machines. Then there is micro VMs and high isolation, which we know from our cloud friends. And obviously, sometimes the best alternative is to realize that Kubernetes might not be the best tool for a heavy legacy VM workload. And there are obviously also like really nice open source tools like Proxmox and OpenStack there, where you could like implement something similar to a traditional virtual machine hypervisor infrastructure. That being said, thank you very much. My name is Teemu. I'm from Bern. I'm really liking it here. I've been working with containers and Kubernetes for actually some time. I also am Cloud Native Zurich co-organizer, which just started recently. And I know how much effort it is to bring such a conference to life. So a huge thank to the whole organization committee of KCD Geneva. And I'm really looking forward to the next edition next year, hopefully. Thank you very much.
Thank you, thank you. So we have some minutes for questions. Anyone? One there, please.
Thank you. Thank you. So my question is, you mentioned NVIDIA using KubeVirt for GeForce Now, and at these times of AI and more GPU-intensive workloads, how does KubeVirt integrate with hardware like GPUs, for example?
It actually integrates very well because it runs as process on those machines. The reason why GeForce Now is using like KubeVirt was that their solution prior to the whole migration to KubeVirt was already virtual machine based. So the migration was not like virtual machine to containers. It was like virtual machines to virtual machines which were still running there. They had to adopt some stuff, some plugins, so especially also in the networking stuff and in the device driver field where they needed to integrate all those hardware close stuff directly into KubeVirt.
All right, thank you.
Anyone? That's your chance.
I'll be here later as well, so.
VMs on Kubernetes, what could go wrong? Come on. All right, once again, thank you very much to Thomas.
Thank you very much, everyone.
That was great. All right, so the next panel, actually, which I really like the format, will start in 10 minutes. So please go visit our very dear sponsors. Don't hesitate. There's some stuff to win. We always want swag when we come to a conference. So don't hesitate, and see you in 10 minutes. Normally.
Just a talk. His smile's polite.